Hi, I'm Mark Barsamian. In this video, we'll start discussing the increasing and decreasing behavior of functions, and we'll take an approach of studying functions given by graphs, not by formulas. This material is from section 4.1. It's hard to narrow it down more than that. In my opinion, section 4.1 is not organized very well. The topics don't progress from simple to more complex. I've tried to, in my notes for this video and the coming two videos, I've tried to reorganize the material in a way that it does progress from simple concepts to more complex concepts. So the reading is scattered throughout section 4.1. And the homework exercises from section 4.1 also don't progress in a order from simple to more complex, and they don't progress in the same order as the reading. So our homework problems for this video are this batch of problems that are scattered throughout the homework exercises for section 4.1. Now, we reviewed the idea of positive and negative in the video for homework 20. Remember that a number is positive if it's greater than 0. So if we say that f of c is positive, that means a y value is positive. That means that the point c comma f of c is just simply above the x-axis on the graph. And if f parentheses c is less than 0, that means f parentheses c is negative. That means that the point is on the graph is below the x-axis. And if f of c equals 0, that just means that the point c comma f of c is on the x-axis. We had this example from video 20, and it's worth reviewing because it'll be a contrast to what we do today with the exact same graph. So we had this question: at what x values is f of x 0? Well, that means that if f of x is 0, means that the y value equals 0. So we're talking about points that are on the x-axis. So those are the points in question. The x values for those points are. Also in the video for homework 20, we had this question: on what intervals is f of x positive? So that means on what intervals is the graph of f of x above the x-axis? Well, that means these intervals. I'll color them green. So those green intervals on the number line you could think of as the places where the graph is above the x-axis, kind of like grass above the level of the ground. And then question C, on what intervals is f of x negative? Well, we'll color the axis blue in those regions. So those are questions that we had before. They're about positive, negative, and 0 behavior of a function. Now I want to introduce a new concept, the idea of an increasing function. To say that f is increasing on an interval means this: if a is less than x1, which is less than x2, which is less than b, then f of x1 is less than f of x2. In other words, as you move from left to right in the interval AB, the graph of f of x goes up. And there's a similar definition for decreasing on an interval. As you move from left to right in the interval, the graph of the function goes down. So let's revisit that same graph and answer these questions. First of all, question D, at what x values is the line tangent to the graph of f horizontal? Well, let's draw some horizontal tangents. Those three x values, so that's x equals -7, x equals -1, and x equals 6. All right, question E. At what x values does the graph of f of x not have a tangent line? Well, that's going to be this point. Because if you try to draw a tangent line at that point, remember the tangent line has to look like it's going the same direction as the graph. Well, it would be hard to choose a single direction. I mean, over here the graph seems to be going down like that, but on the right side of that point the graph seems to be going up like that. So it's impossible to choose a single direction for the tangent line to go so that it looks like it's going the same direction as the graph. Certainly the tangent line is not horizontal there. That the graph doesn't look like it's going horizontal at all. So at that point, x equals 9, the graph does not have a tangent line. All right, question F. On what intervals is f of x increasing? Well, that's going to be this chunk of the graph, where as you move from left to right, the graph goes up, and also this, also this chunk of the graph. So we have to describe those using intervals. Notice those are intervals. Those are not x-y pairs. This does not refer to a location on the graph. When x is -7, the y value is -1. It's kind of a strange coincidence, but it's talking about the portion of the graph from x equals 7 to x equals -1. So when you see this symbol, it's ambiguous because it could stand for, in some situations, a point on a graph, but in this situation it stands for an interval. Now this symbol, of course, could never stand for a point because the symbol infinity does not represent a number that could be a y value. All right, question G. On what intervals is f decreasing? Well, that's referring to this chunk of the graph and this chunk of the graph. As you move from left to right in those blue chunks of the graph goes down. So that's everywhere to the left of -7 and everywhere from -1 to 9. Now I want to talk about a correspondence between the sign behavior of a function at a particular x value and behavior of the graph at the x value. The first correspondence is this. If f prime parentheses c is positive, well, remember f prime parentheses c means the number that's the slope of the tangent line at x equals c. Well, if that number is positive, then that just means the line tangent to the graph of f at x equals c tilts upward. If f prime parentheses c is negative, well, that means that the line tangent to the graph of f at x equals c tilts downward. And finally, this third one has a typo in it. This should say if f prime parentheses c is 0, remember f prime parentheses c is the slope of the tangent line. If that slope is the number 0, then that means that the tangent line is horizontal. Now I want to talk about a correspondence between the sign behavior of a function f of x on a whole interval ab and behavior of the graph of f of x on the whole interval ab. So the first correspondence is this. If f prime is positive on a whole interval a comma b, then f of x is increasing on that whole interval. And if f prime is negative on a whole interval, then f is decreasing on the whole interval. So we're talking about f prime being negative and f being decreasing. And the third correspondence is if f prime is 0 on a whole interval, then f of x is constant on the whole interval. So let's return to that same graph and answer these questions. H, at what x values is f prime of x equal to 0? Well, remember, the only way that f prime of x can be 0 is for the tangent line to be horizontal, and that happens at these 3 x values. Question I, at what x values does f prime not exist? Well, f prime is the number that's the slope of the tangent line. Any place there's a tangent line that has a slope, then the f prime does exist. Well, we see that there's no tangent line there. So f since there's no tangent line, there can be no number that's the tangent line slope, so f prime does not exist at x equals 9. On what intervals is f prime positive? So that means on what intervals is the tangent line sloping up? Well, we can see that on this whole interval, all of those tangent lines have a positive slope. And also out here on this interval, all of those tangent lines have positive slopes. Now, on what intervals is f prime negative? Let's look for tangent lines that slope down. Certainly out here, all those tangent lines slope down. So from negative infinity to negative 7. And let's see, in this interval here, all of these tangent lines are tilted down. So from negative 1 to 6. And also in this interval, from here, we can see that all of these green tangent lines in this region of the graph tilt down. Of course, right at x equals 6, the tangent line doesn't tilt down. So that's one of the places where f prime is 0. So we had to break up this chunk of the graph into two intervals where f prime is negative. Now notice that the answers to G and K are not the same. In question G, we found that f was decreasing on this whole interval from negative 1 to 9, because as you move from left to right in that interval, anywhere in that interval, if you move from left to right, you go down. But when we asked on what intervals is f prime negative, we had two separate intervals. This interval, this chunk of the graph, and this chunk of the graph, but not the whole chunk. We couldn't say that f prime was negative on that whole interval. So that illustrates something very important. We learned that if f prime is negative on a whole interval, then f is guaranteed to be decreasing on the whole interval. But it does not work the other way around. If you know that f is decreasing on a whole interval, we're not guaranteed that f prime will be negative on the whole interval. So what we just saw was our function f was decreasing on the whole interval from negative 1 to 9. But it is not negative. F prime is not negative on the whole interval. F prime is only negative on these two chunks of the interval. Example 2. We want to match the graph of f to the sign chart for f prime. So we've got 5 graphs and we've got 5 sign charts. Well, let's start with this graph over here on the left. First of all, notice that it has a horizontal tangent at x equals 3. So that means that the sign chart for f prime is going to have a 0 at the place where x equals 3. Well, that could be this one, or this one, or this one. So one of those 3 sign charts goes with that circled graph. Now let's look at some other aspects of this graph. Notice that to the left of 3, this graph has tangent lines that tilt up, and to the right of x equals 3, this graph has tangent lines that tilt down. That means the slope is positive to the left of x equals 3, and the slope is negative to the right of x equals 3. We have to have a sign chart for f prime that has the signs of f prime positive to the left of 3 and negative to the right of 3. That's this one. F prime is positive to the left of 3, f prime is negative to the right of 3, and again, f prime is 0 right at x equals 3. So this first graph goes with the 4th sign chart. Let's go on. What about this second graph? Well, that graph has a horizontal tangent at x equals 3 as well. So that means it's going to have to correspond to either this sign chart or this sign chart. Well, let's look at the slopes of the tangent lines. To the left of x equals 3, the tangent lines have negative slope, and to the right of x equals 3, the tangent lines have positive slope. So the corresponding sign chart for f prime will have to have f prime being negative to the left of 3 and positive to the right of 3. That's this sign chart. F prime is negative to the left of 3 and positive to the right of 3 and 0 right at 3. So the second graph corresponds to this first sign chart. Now let's look at the third graph. The third graph, let's start by looking at the slopes. To the left of x equals 3, the slopes are negative. And to the right of x equals 3, the slopes are positive. Just as they were with this graph just to the left of it. Well, that means that our sign chart has to have the sign of f prime, our sign chart for f prime has to have f prime being negative to the left of 3 and positive to the right of 3. That's got to be this sign chart. That's the only sign chart left that has that signature. But what's up with this ND? What does that mean? Well, notice that on this graph, right at x equals 3, there's no tangent line. So since there's no tangent, there's no number that's the slope of the tangent line. And since there's no number that's the slope of the tangent line, that means the derivative does not exist or is not defined. So that third graph has to correspond to that sixth or that fifth sign chart for f prime. Okay, let's go on. What about this fourth graph? Well, let's notice that this graph has a horizontal tangent at x equals 3. And of our remaining sign charts, let's see, only this one has the property that f prime equals 0 at x equals 3. Let's double check the behavior of the tangent lines. The tangent lines tilt down to the left of 3, and they tilt down to the right of 3 also. So the tangent lines have negative slope everywhere in that graph except at x equals 3, where the tangent line has a slope of 0. So that corresponds to this sign chart for f prime. F prime is negative everywhere except right at x equals 3. So that fourth graph corresponds to this third sign chart. Now let's look at this fifth graph. First of all, look at its slopes. There, the tangent line has negative slope. And there, the tangent line has negative slope. That corresponds to this behavior. But what's up with this ND in the middle? Well, look at this graph. In the middle, there is a tangent line. We haven't talked about vertical tangent lines before, but there's a vertical tangent at x equals 3. So there is a tangent line, but remember that vertical lines have undefined slope. Well, the number that's the slope of the tangent line is the number that's the value of the derivative. If the slope of the tangent line is not defined, then the value of the derivative is not defined. So that fifth graph corresponds to the second sign chart for f prime. Notice that we have seen now two ways for the derivative to not be defined. The derivative can be undefined because the graph doesn't even have a tangent line. Or the derivative can be undefined because the graph has a tangent line, but the tangent line is vertical. All right, let's go on. In example 3, we're given information about a function, and we have to sketch its graph. The information that we're given is, first of all, the function is continuous. And then we're given this table of x, y values. And then we're given this sign chart for f prime. And we're supposed to graph f. Well, I find it helpful to translate information about f prime into information about f. So we're going to translate the information about f prime, which is information about the sign of f prime. So how do we translate that? Well, we're going to translate it into information about the increasing, decreasing behavior of f. So let's go back up and review our correspondences. If f prime is known to be positive on an interval, then that tells us that f is increasing on that interval. And if f prime is known to be negative on an interval, then f is decreasing on an interval. And let's go back up earlier. If f prime parentheses c is 0 at some x value, then the line that's tangent to the graph of f at that point is horizontal. You know, back here I should have drawn some pictures to illustrate this. So let's go back down to our example in progress. So we are given information about the sign behavior of f prime. So we need to translate that into information about the increasing, decreasing behavior of f. Well, on this interval, f prime is positive, so that means that f is increasing. On this interval and on this interval, f prime is negative, so that tells us that f is decreasing. So it's important to segregate the information. We have, in this sign chart now, we have information about f prime, which is this stuff up here above the number line. And then below the number line, we have information about f. So f prime is the thing that's positive. F is the thing that's increasing. You have to keep those two function names straight. We have two functions kicking around now. We have f prime and we have f. Now what about the behavior at those x values of -1 and 1? F prime has the value 0, so that means f has a horizontal tangent line. So again, f prime has the value 0. What that tells us about f is that it has a horizontal tangent line. So now we have a bunch of information about f. We have these function values, which can be used to give us points on the graph. And then we have this information, which can tell us about the shape of the graph. So let's start by plotting those points. So this gives us a point -2, 1. This gives us a point -1, 3. This gives us a point 0, 2. This gives us a point 1, 1. This gives us a point 2, -1. Now, if that was the only information we had, and we were told to graph, then we would be tempted to just draw a graph that goes through all those points, like this. Just connect the dots. But that's not the only information that we have. We have this additional information. So we have to incorporate that into our graph. So first of all, let's start by putting the horizontal tangent lines in. So our graph has to go through all those points, but it has to have that tangent line behavior. And then the graph has to have this behavior in between. It has to be increasing to the left of -1, and this tangent line is supposed to be here at x equals -1. And then decreasing until it gets over to here, where it has a tangent line. Well, let me just draw the graph at this point. So notice the graph actually is decreasing everywhere to the right of x equals -1. How does that square with this sign chart? Well, the sign chart guarantees that f has to be decreasing on that interval and f has to be decreasing on that interval. And it requires that f has a horizontal tangent line at x equals 1. But in fact, you can see that f is still decreasing on this whole interval. All right, let's go on. Here's a similar example where the information is given in terms of intervals instead of a number line. So we're told a bunch of information about f prime, but it's not in the form of a sign chart. Well, so let's do what we did before. Let's translate this given information about f prime, about the sign behavior of f prime, translate that into corresponding behavior of f. All right, so when we translate this sign behavior about f prime into information about f, it's going to be information about the increasing, decreasing behavior of f. So this information and this information tells us that f of x has horizontal tangents at x equals -1 and x equals 1. This information tells us that f either does not have a tangent line at x equals 0 or has a vertical tangent at x equals 0. And finally, this information about f prime being positive on that interval tells us that f is increasing. And this information tells us about f being decreasing. Well, let's make a graph that satisfies all these properties. So first of all, these function values, 3 ordered pairs, -1, 2, 0, 0, and 1, -2. Okay, horizontal tangents at x equals -1 and x equals 1. And then the function has to be increasing from to the left of -1 and to the right of +1, and decreasing from -1 to 0 and from 0 to 1, but either has to have no tangent line or a vertical tangent at x equals 0. So look, we can do this. We can have a tangent line that's vertical at x equals 0, and our graph is decreasing here. It's also decreasing here. And in fact, you can see the graph is actually decreasing on this whole interval. So that graph satisfies all of those given requirements. Okay, let's go on. Example 5. Given this graph of f of x, answer these questions. So here's a graph of f of x. We're supposed to answer these questions about f prime. So find the intervals on which f prime is greater than 0, and f prime is less than 0, and find the x values for which f prime is equal to 0. Well, hey, let's start with the third question, because that'll be easy to spot. The places where f prime equals 0 are the places where f has a horizontal tangent. And those are x equals -3, 1, and 3. Now the intervals on which f prime is greater than 0, well, those are going to be the intervals on which the tangent lines are sloping upward. You can see that the tangent lines slope upward in that interval and also in this interval. So those two intervals are the intervals where f prime is greater than 0. What about the intervals where f prime is less than 0? Well, those are going to be the intervals where the tangent line is sloping down. There on that interval, and also out here. All right, let's go on. We're supposed to sketch a possible graph of of f prime? Well, let's get our collected information about f prime. We know that f prime is equal to 0 at those three x values. So let's put those points on the graph of f prime. What else do we know? We know that f prime is greater than 0 on these intervals. Now remember, the f prime being greater than 0 means the graph of f prime has to be above the x-axis on the graph of f prime. So on these two intervals, the graph of f prime has to be above the x-axis. Something like that. The graph of f prime just has to be above the axis. Now let's go back up and look at more of our given information. F prime has to be negative on these intervals. So there's a crude graph of f prime. Of course, now that we get the idea, we can clean it up a bit. We could erase all those lines and just make a nicer looking graph. So there's a good example of a graph that behaves that way. Okay, let's go on. In this example, we're given a graph of f prime. We're not given a graph of f. We're given a graph of f prime. Our goal here is to sketch a graph of f. It's the opposite process of what we did in the previous example. The previous example, we started with the graph of f, and we scrutinized it and made observations about how f prime would have to be behaving, and then we made a graph of f prime. In the current example, we're given a graph of f prime, and we're going to scrutinize it with an eye towards making a graph of f. Well, what are we going to observe about f prime? We're just going to observe when f prime is positive or negative or 0. Because remember, we know correspondences between behavior of f prime, the sign of f prime, and behavior of the function f. So we're going to break the domain up into a bunch of chunks, and on each chunk we're going to observe behavior of f prime. So first of all, this chunk, when x is less than negative 3, is f prime positive or negative or 0? Well, on that chunk of the graph, f prime is above the axis, so f prime is positive. Notice f prime is decreasing, but that's not the same thing. The y values on this graph are positive because that graph is above the axis, so f prime is positive. Now let's move to this chunk of the graph, x equals negative 3. What's happening with f prime there? Well, we have an x-intercept there, so f prime is equal to 0 there. Now let's move to this part of the graph, from negative 3 to 1. This part of the x-axis, this part of the graph. What's the behavior of f prime on that part of the domain? Well, this graph is above the axis, so f prime is positive on that interval. What happens right at x equals 1? Well, that's this point. Now, notice there's a horizontal tangent line, but that's not one of the options for describing the behavior. We have to say, is the y value there positive or negative or 0? The y value there is positive. The y value is not 0. If we had a tangent line, we'd say the tangent line is horizontal. It has slope 0, but that's not the question. The question is this y value positive or negative or 0? Let's go on. Let's look at this chunk of the domain, this chunk of the graph. Are the y values there positive or negative or 0? Well, they're positive because this graph chunk is above the axis. I want to do that in green. This whole chunk of the graph is above the axis. It's coming down. The graph is coming down there, but the y values are positive. So this exercise is all about keeping straight in your head the idea of positive or negative versus the idea of increasing or decreasing. Now what happens right at x equals 4? Right there. Well, you see at that point there's an x-intercept. So at that point the value of f prime is 0. And the last question is, what's happening on this part of the domain out here? Well, those y values are negative. Now, our job is to translate that into behavior of f. Well, remember that if f prime is positive on a whole interval, that means that f is increasing on that whole interval. Now you can see that on this whole interval from -3 to 3, f prime is positive on that whole interval. So that tells us that f is increasing on that whole interval as well. And what about this interval? If f prime is negative, that tells us that f is decreasing. Now what about these places where f prime is 0? When f prime is 0, that tells us that f has a horizontal tangent. All right. Our job now is to sketch a possible graph of f of x below. Well, let's go back up and look at our information. What is helpful to start with is this. At x equals -3 and at x equals 4, f has a horizontal tangent. Where, though? Well, x equals -3 is here, and x equals 4 is here. So how does it look for f to have a horizontal tangent at that point? Well, we don't know where the graph is at those x values, but we do know that wherever the graph is, it's going to have a horizontal tangent. So we could just do this. We could just put a bunch of potential tangent lines. Again, we don't know how high the graph is, but wherever it is, when it flies across x equals -3, it's going to have to be horizontal. And same thing at x equals 4. It's almost like these are Venetian blinds, and the graph has to shoot through these Venetian blinds horizontal. Now let's go back. We know that to the left of 3, to the left of x equals -3, the graph has to be increasing, and between -3 and 4, the function has to be increasing. So we know the graph has to be going up and has to be going up again. And then we know that to the right of 4, f of x has to be decreasing. So out here, the graph has to be coming down. So we can draw one possible graph just by following those instructions. We have a graph that is coming up. It's got to fly through these Venetian blinds horizontally and then start going up again and then be horizontal and come back down. So there's an example of a graph of f that does that. That's the end of this example, and that's the end of the video. Thank you.